All right, let's talk about circles. So, write an equation in standard form for the given center and radius. Okay. Ooh, there's all sorts of nifty stuff I want to do right now. Let's see. I'm going to take a look, though. Can I make a circle? How to make... So, Microsoft has changed things lately. Oh, look at that. I don't know what all this is about, but I like it. Yeah, that'll be fine. I don't need anything fancy. Whoa. Hey, ever since the update, it's felt a little different. But that is okay by me. I'm okay with it as long as it does what it's supposed to do. You know, like, just keep it simple. One thing I don't like that it seems to now the eraser does not appear to like actually erase things in parts and pieces. You know, like if I wanted just part of this to be gone. Well, first of all, it's not even doing it there. Or maybe I wanted to erase just some part of the image up here. Wow, none of that's okay. Hold on. This is interesting. This is not supposed to be me. Okay, let's say I want to erase part of it. I need to break this line up. The whole thing disappears now. I don't like that. That bothers me. Oh, well. But anyway. So, write an equation in standard form for the given center and radius. And let's see. How nifty can I get with this thing, though? Let me see here. Well, I'm just going to... Radius. Instant radius. We have created a radius just for you. Look at that. Okay. Oh, look. And I can get it right. Can I get it right in the... Well, I want it right in the center. That's okay. This looks pretty good. That looks pretty close. Lock. Yeah, you bet. Lock it. Okay. Lock and load. All right, we're good. That's, sorry, my voice is a little hoarse from classes. Let's take a look. Okay, so here's our circle. So, of course, by the center, just to be sure we're all on the same page here. There's the center, right? Let's mark that C. That is a tiny C. Mark that C. Oh, well. And this will be, of course, R, the radius, the length of the radius. Circle is pretty straightforward, but we're not going to go into the basics of circles today. What we're going to do is talk about, if I know how long R is, which in this case is 10, and I know where the circle is, then how do I write an equation for it? So first, and before we even cover that, let's talk about what they mean by standard form. So you've seen standard form, say, in quadratics and stuff. You're probably thinking, okay, something like this, right? Ax squared. That's supposed to be a plus sign, my friends. Let us try again. There we go. Bx plus c, right? And then maybe that's equal to 0 if I'm lucky and I find the zeros and all that. That is true. That is... Standard form is kind of ambiguous. If you don't know what you're talking about, standard form could be anything. If they ask for quadratic standard form, you'd be right. But we're not talking about quadratics. No, we're not talking about parabolas. We're not talking about anything. In fact, the only thing closely related at all is the whole topic of conics sections. But we're not talking about that. We're talking about circles. So we got to get clear. Got to get nice and clear. This is about circles. Okay? So standard form for circles. I could memorize it. What I'll do is I will show it to you as... We're going to talk about ellipses in another video here shortly. So what I'll do is I am going to start with circles. Actually, what I'm going to do is I'm going to do you one better. I'm going to start with something you already know. I'm going to start with a squared plus b squared equals c squared. That's good old Pythagoras right there. Pythagorean theorem. Apparently not from him, by the way. The Babylonians were using this stuff way before he was. Probably it was discovered in China. Probably, I don't know how many hundreds of years before him, but they started using it too. It's all lots of different civilizations used this thing before Pythagoras. So he's just the guy who planted the flag on it. I hate it when that happens, you know? I mean, it's not like it's happened to me personally. That's kind of dumb. But, you know, that somebody would at the end get to say, hey, this is going to be named after me. Or somebody had to decide that at some point. Maybe Pythagoras is the wrong person to duel this out with. But whoever chose that name just was disregarding so many other people. Okay, stop talking about this, Kelsey. Where are we going with this? So here's the point. A squared plus B squared equals C squared. Imagine, and I'm going to get all fancy again. Imagine, ooh, let's see, what can I use here? Yeah, it's an arrow. I like this. I like this thing. I can get used to this. So I'm going to use this arrow, assuming it'll let me play around with it. Yeah. So imagine this arrow kind of pointing any particular, so yeah, there's the radius, and if I were being a little bit more exact, I'd put it where the radius is. There we go. And so this thing, should be equal distant. This is not a perfect circle. I did a pretty botch. You got to do a pretty sketchy job. Excuse me, scratchy voice, sketchy job of drawing the circle. Almost more of an ellipse, but let's pretend it's a perfect circle. So this radius would be the same all the way around. So what on earth does Pythagoras' theorem have to do with this thing? Well, if I were to stop at any given point, the whole point of this equation is to give me a sense of the standard form of the formula for circles, I should say. What that equation, when we see it, is going to do is give me an output and tell me where to find any given point, any x or y. So this thing is being graphed. That's my attempt to draw a plane. A coordinate system, Cartesian coordinate system, of course, which we're going to actually do for realsies now. Let's do this for realsies. If I'm going to do that again. Okay, let's see. We'll keep it as lines. So here's my y, of course, and I want one more line, please. Do I have to? Yeah, good. And there's my x. Actually, this is got to be on the negative side since I'm over here, and I'm going to put this way down here. Okay, because we already know where the center is. Let's think about what we know about this thing. We know the center is at negative 1, 4. So C equals negative 1, 4. That is the point coordinate for the center. And what we want to figure out is asking ourselves, and of course, and the radius equals 10. So let's think about this really first, just kind of basically, before I get all into why this is relevant and how this can help us remember the equation better. Because if we know this, we can figure it out very easily and understand very easily what's going on here. So what is it? What does it mean if we were to just like measure from here to here, right? That is, imagine the question is, okay, I want to know what this point is. That would be easy, right? We just start from the center. This is at negative 1. The y value is going to be the same. So we would have negative 1. Stupid. I'm sorry. Just tired. Something 4. So y's coordinate is going to be the same. Negative 1 plus what? Negative 1 plus 10. You can probably tell already, by the way, that this is completely messed up. I was trying to get these lines out of the way, but if I'm going to be real about this, and I should be real about this, it's got to be more like here, right? If this thing is 10, in fact, it's got to be something like there. So we are going to move into we would be moving into anyway, can I change the color? Maybe that would help. Can I change is it too late for me to change color? No, it's not. Gray. Yes. I like this. I like this system. Okay. I would like to send it to the back too. Can you do that for me? Send to back. Yeah, now we're talking. Okay, so this is my x and my y. So negative 1 here, add 10 to it. Well, negative 10 or negative 1 plus 10 is, of course, going to be 9. So there is that point. So that you're like, okay, well, that's an easy one, right? That one's not bad. I get that. So let's work our way up to then what is really important. What if I need a point anywhere else on the circle? And again, this radius, this thing is going to stay 10 no matter where I turn it. Oh, did I lose? Wait a minute. Now hold on. This may be a game changer here. You're not going to let me move my arrow anymore? Yeah. Well, you stink. Well, okay. I shouldn't say that. I shouldn't criticize the program that's letting me do what I want to do, but okay. Anyway, so that's also going to be 10, obviously. And so would any other line here. That's the point. That's what a circle is. We could say, can get really, really technical and say it's the locus of points equidistant to a given origin point or center. I shouldn't say origin, but center point. Origin is specifically talking about 0, 0 down here. Anyway, so let's say I want to know what this point is. How do I figure that out? How would I figure that out? Well, it's actually easier than you think, but we're not, again, going to get into too insane about this right now. Let's just say that if I think about it, it's going to have some sort of an X and Y coordinate, isn't it? And there's a triangle in there. There's a hidden triangle. There's always these triangles. Whenever we see and think of circles, we really should be sitting to some extent and thinking about triangles. So there's a right triangle in there. And what do we know about right triangles? Pythagoras' theorem is the way we would understand a right triangle. Now, we don't need to actually do anything more except this. These sides would be different, right? Instead of A, we should call that, well, we should probably call it X, because we care about the X coordinate, and this corresponds to the X side, you could say. So we're going to call that X. So that in our new circle formula, instead of A squared, this is X squared. And hopefully you can see where this is going. This has got to be Y, right? That's got to be Y. How incredible. Yes, A becomes X squared, and B squared becomes Y squared. Oh, ingenious. So what is this now? Uh-oh. Now we've got a problem. Now we got to think about this. What is that going to be? Well, that's where we're going to have to think hard about, not too hard. I don't mean to make this sound kooky, but think hard about, again, what these sides mean. So this side in its entirety is the radius, but that's not what we're talking about when we say X squared. We're talking about just this side. So ignore the circle for a second. Look at just the triangle. How long does this have to be? This must be the same, though, as the length of the radius of the circle we were thinking about before. So it would be 10 squared here, but we're just going to say in general, the formula would have to be r squared. So if c squared is the hypotenuse to our right triangle, then here the hypotenuse, this is r squared. It's just another name for that one. It's just another name for the hypotenuse. Hip, hip, hooray. This is great. Okay. Now what? Now we've got to actually solve the problem. So let's do that. By the way, there. That's a little less crowded looking. I like that. Okay, so this is, of course, Pythagoras' theorem. I like to call it, actually, to be honest, I call it this precisely. You heard the vehemence in my voice around Pythagoras didn't invent that. I can't write an A tonight. That's how tired I am. Pythagorean theorem, as I like to call it this, because this is kind of like, yeah, well, Pythagoras used it, but it's Pythagorean at best. It's not his formula. Okay. Stick it to the man. Not really. Didn't really change anything with that, did I? X squared plus Y squared is R squared. This is the formula. That's the circle formula. That is the standard formula for circles. Now, write an equation for it. So what do we do? What does that mean, write an equation for it? Does that mean I have to know what the length of this is and the length of this is, knowing that r squared is 10? Well, it's true. It's true that we already know what to plug in for r, right? That's what's cool. So let's just go on and change what we know. We know that r is 10. So let's put in 10 squared. And of course, we know 10 squared is really 100, but we'll change that in a moment. So far, so good, I hope. X and Y, we don't need to know what X and Y individually are. That's not the point. We need it's a standard form equation for if I wanted to know any specific given point. But I don't, at this moment, want any specific given point. I just want all the points that are possible for me to choose. So for the whole circle. Otherwise, it would just be, it'd be that. That's all it would be. It would be some point in space. But I want to know what all the points are around a given center, the locus of points around a center. That's what a circle is. So I want the ability to plug in an X and an Y whenever I want. So you might be thinking, okay, well then, cool. I'll just keep those as they are. And bam, we're done. Except for one thing. What this circle, or I should say this equation, what this equation would indicate is a circle down here. Well, why is that? Because this is the circle at the origin. At the origin. There's an easy way to see what's going on here. Imagine that we started with some original, let's just call it XO, YO, which is, of course, the origin. We know that's 0, 0, but just okay, or actually, let's call it 0, 0. Let's make it easy on ourselves. Let's call it 0, 0. Let's call it 0, 0. Right, 0, 0. That's the origin, right? And so what then would this be? Well, this would have to be 0 plus, that, except that, we don't actually want to add to it. We want this to be the new origin, we could say. It's kind of like what we want to do is we want to imagine, instead of trying to we're not trying to move this point to here. What we really want to do is imagine what would it take to move the center back to the origin. I hope that makes sense. So in other words, what we would want to do is we'd want to, to get this into the origin so that we can just talk about everything being around the origin, we'd have to subtract, for y, we'd have to subtract 4. And to get this back on the x-axis to begin with, we'd also have to add, not subtract, right, but add 1 to it. So adding 1 to x would bring it here, and subtracting 4 would bring it here, and we would have it where we want it, so that we don't confuse just any old equation with the one that's currently up here. And then the new equation, however, after we add to y and subtract to x, and we're technically subtracting both, but don't worry about that. It will indicate, it'll actually stand for the real position of where this is in coordinate space. So what does that mean? That means we've got to do now x, and we're going to put this on the insides here, because this is, if you imagine, it's like x minus 0 if it was already at the origin. Now instead it's going to be x plus 1. It's really an x minus negative 1. We're really just using a negative all the time. So let's write it that way the first time around, okay? Just so that we're clear in what's going on here. So we're going to say x minus negative 1. Yeah. And then we're going to add y, only this is now y minus 4, right? We need it to drop down by 4 to get back to the origin spot. And let's just go on and make this into 100. We know that's what this is. Okay. And now if we clean it up, negative into negative makes a positive, right? So x plus 1 squared plus y minus 4 squared equals 100. Ladies and gents, this is the answer. Now, why did I go through all that rigmarole just to tell you that? Well, I've seen so many students make this mistake where they say, oh, okay, I see. So the origin has to come up by 4, so I'll add 4. Ooh, that's a straight line. How did I do that? Anyway, I'll add 4 to y, and then I will subtract 1 from x. So they would have x minus 1 squared plus y plus 4 squared. This is incorrect. That is not true. We need to subtract. We want to subtract because what we're doing is we're trying to, in a sense, envision how to orient this with a new origin. We could call it the new origin, where we or let's call it the new center. That makes more sense. The new center, a center where it's at the origin, so then we can just describe at any given point. This is really great. I'm going to show why this is so useful. At any given point, if I want, say, the point, well, let's say I just choose a point like, I'm going to have to be careful here because I don't know exactly. Well, let's say I've got an idea. Sorry, I'm getting there. Let's say I want to know this point or where it actually is on 0. That'll be an easy enough one to do. So I want to know when x is 0. What about when x is 0? I want to know what this new point is. All right. So if that's what I want, let me see. Let me grab something real quick. All right. Just don't want to forget about that later. Okay. So if I want to know what that point is. I wish I had blue. I'm going to make blue happen. Make blue happen now. Yes, thank you. All right. I want to know what that point is. And if you're done by this point, just stop the video. But I want people to understand why this is a useful thing. What would you need an equation for a circle for? Well, let's say that I need to know. I know what the given distance from my house is, but I have a latitude or something here. I need to know, though, what the longitude is going to be. Something along those lines. It's not exactly what's going on here in this case, but let's say that it was something like that. So I want to know what the y is. Let's call this y tilde, because it's a new y. It's not the same as this y here or any other y. It's a y tilde. I want to know what y tilde is. So if I had to figure this out, I would just plug it in. That's the coolest part. I can just plug in. So I'd put in 0 plus 1 squared plus y tilde minus 4 all squared equals 100. And I could solve from here. This will be 1 squared is going to be 1 plus, all right, I'm going to have to, well, actually, all I'm going to do is I'll subtract, let's do this. I'll just go on and do the dirty work here. Now I'm going to subtract 1 from both sides, so I've got nice pretty y tilde minus 4 squared equals 99. Take the square root of both sides, so now that's canceled. And then I will, I don't want to figure out what the square root of 99 is right now, but if I were to add 4, then whatever y tilde is, it's going to be equal to 4 plus square root 99. Hold on, let's see. That's 33 times 3. 33 is not a prime. That's going to be, 9 times 11. Okay, that's going to be 3 root 11. Taking too long to think through that one. 4 root 4 plus 3 root 11. That's pretty cool. I think it's phenomenal. So it's a little above 4. It's not 5. It might be 5 actually. Let's find out how much it is. I would imagine it is 5 because 3 by itself, so it's got to be over 7. Being kind of dumb at the moment again. I'm tired. Please forgive me. 3 root, let's see, we're going to have to do this backwards. 11, I need the square root of 11 multiplied by 3, add 4, and we actually get, 14? Let me think about that. Yeah, it's not quite 14. That's what's cool. It makes sense if the radius is 10, if it were straight up, would be 14, wouldn't it? Adding 10 to the 4. So this is not quite 14. It makes sense. It's on its way up towards, but isn't quite 14, but rather is something closer to 13.95. That's awesome. See, I love this. I love this stuff. Okay, that's it for now. More soon.